Hello viewers, today we want to learn mathematics for 3 topic errors and approximations, subtopic propagation of errors. Specifically, we want to look at addition. For instance, you are given 4 plus 2. You are asked to find the limit within which the sum lies, the absolute error in addition, C. Relative error, D. Percentage error. So our solution will be as follows. We need to look at the least unit of measurement. Into bracket I have abbreviated is at LUM. So this list of units of measurement is the one which will give us the limits. That is the upper limit and the lower limit within which the individual measurements, that is the 4 and 2, will lie. So our limits will be added with a half of the least unit of measurement. So our least unit of measurement was 1. So 1 divided by 2, we get 0.5. That is 1, which is our least unit of measurement here. This is our least unit of measurement, loom, least unit of measurement. You are dividing by 2. Why are we dividing by 2? This is because 4 must be bounded with the upper limit here and also the lower limit. And our least unit of measurement was 1, isn't it? And then we are having the two limits, the upper and the lower. So we need to divide by this one by 2. So after dividing by 2, we get here, it will be 0.5. It will be 0.5 there, plus 0.5, and here 0.5, which need to subtract between this. We get 3.5, the lower limit, which is now 3.5. And also the upper limit for this one, we do add 4 plus 0.5, we get 4.5. So let us embark here. So for the maximum limit will be 4 plus 0.5, which is 4.5. The lower limit will be minimum limit, or the lower limit will be 4 minus 0.5 is 3.5. The same occurs to 2. The least unit of measurement was 1, which we divided by 2, we get 0.5. To get the maximum value for 2, it is 2 plus 0.5, which is 2.5. The minimum, it is 2 minus 0.5, which is 1.5. Then we come to the actual sum, or the working sum. The working sum, we go to the individual numbers 4 plus 2 as they were initially, which is now 6. After that one, we need to go to the maximum sum. So for this maximum sum, we need to get the maximum for the first number, which is 4, and the maximum for the second number, which is 2, which is 4.5 plus 2.5 is 7. Minimum value will equal to minimum for the first number and minimum for the second number, which is 3.5 plus 1.5, which is what? 5. The limits within which the sum lies will be as follows. So we write this limit by using this inequality sign. This one means it's less than or equal to. So if it's less than or equal to, we write here the maximum value. For instance, what we were calculating was the sum, so we write the maximum sum here on the right hand side of this inequality. So another one is, this one means the sum is more than or equal to. So here you indicate the minimum value of the sum. Or you can use the actual sum here instead of just writing sum. So you write 6 is greater than or equal to 5, and 6 is less than or equal to 7. Then let us come to the absolute error in the sum. So when we talk about absolute, we need to get the actual number irrespective of the sign. So if we mean that irrespective of the sign, when you subtract the lower number from the upper number, or the upper number from the lower number, one of them might be negative. To avoid that negative, we normally use these two parallel vertical lines so that it can change that number. If it was negative, after subtraction you get a positive. This is what I mean. For instance, if you are having 8 minus 2, you get what? 6. And 2 minus 8, you get negative 6. Because we want to get the absolute value, so we put this sign so that when it's a positive, it remains to be positive. So which is now 6. The same here, 2 minus 8 here, 2 minus 8, 2 minus 8, it will be negative, but we want the absolute value of it. So we put these two lines so that we can get 6. So if it's a positive, it maintains to be 6 positive, and if it's a negative, it becomes positive. Let us back on our calculations. So like now, absolute value here will be now the maximum value minus the minimum value divided by 2, because we are at the extreme ends here. We are extreme ends. We want to get, now we divided by 2. So it is 7 minus 5 divided by 2, which is the same as 5 minus 7 over 2, which is the same as 2 over 2, which is the same as what? 1. So the absolute value in the sum of 4 plus 2, the sum of 4 plus 2 will be what? 1. Then let us go to the third solution, the relative error. The relative error we normally denote by RE, we abbreviate by RE. So how do you get the relative error? We're equal to absolute error, that is AE, over the actual value or the actual sum, which is now 1 over 2. Then we come to the percentage error, which will equal to relative error times 100. And what's now the relative error? The relative error is absolute error, which is 1. Now what is now absolute error? 1 over 2. So simply it's a relative error times 100, which is 50%. Or somebody might say our percentage error, it will be now our absolute error of actual value times 100, which is now the same. Let us go to more examples. Let's go to more examples. Find the limits within which the sum of 6 plus 3 lie. So when you are given such a number there, you just write the word solution. Now let us go and look at what we have learned. So we start with the least unit of measurement. The least unit of measurement of 6 and 3 is 1. So is 1 over 2. We get what? 0.5. So we must get the limits for 6, which is 6 plus 0.5 becomes 6.5, and the lower is 6 minus 0.5. We get what? 5.5. The same for 3. 3, the least unit of measurement was 0.5, so the maximum will be 3 plus 0.5, which is 3.5. 3 minus 0.5, which is 2.5. So the limits. Let us come to the limits. The limits. The limits, we must get the actual sum, which is 6 plus 3, which is 9. So we write sum. The minimum is, the maximum is, the maximum is what? 6.5 plus 3.5, and the minimum is 5.5 plus 2.5. So 5.5, let us add 5.5 plus 2.5, we get 8. So it's 8 is less than or equal to the sum, is equal to 6.5 plus 3.5. 3.5. Oh, this is 3.5 here. Sorry, this is 3.5 here. So what do you have there? 3 plus 6, 9, plus 1 is 10. So let us get the absolute error. Absolute error will be maximum 10 minus 8 over 2. This 2 over 2, which is 1. And also the percentage relative error. The error will be one absolute error of actual value times 100, which will equal to what? To equal to a half. To equal to half. Example 2. Example 2. In our example 2, we need to adjust these numbers so that one can be one decimal place, another one to be even a whole number. Example, given 2 plus 3.0. Find the percentage error. Percentage error. So first of all, we need to start with the least unit of measurement. The least unit of measurement for 2, least unit of measurement for 2 is 1. So limits for 2 will be 2 plus 1 over 2. 2 minus 1 over 2, which is 2.5, which is 1.5. Least unit of measurement for 3.0 is 0.1. So the limits for 3.0 will be 0 plus 0.1 over 2, 3.0 minus 0.1 over 2, which will equal to what? Which will equal to 3.0 plus 0.1 over 2, 3.05. 3 minus 3 minus 3 minus 3 minus 3 minus 0.1 over 2, 2.95. And then the maximum sum will be 2.5 plus 3.05, which is equal to 2.5 plus 3.05, 5.55. Maximum sum, minimum sum will be 1.5.95, 1.5, 2.95, 2.95, 4.45. Actual sum will be 2 plus 3.0, which is 5.0. After getting the actual sum, the maximum sum, and the minimum sum, we go to the percentage error. What's the percentage error? So percentage error will equal to absolute